Hello everyone. In this course, we will learn how to model a control system and how to perform a co-simulation with dynamic mechanical systems in addition to the basic control theory. In this course, we will use software called RecurDyn for the dynamic mechanical system and CoLink for the control system. Let me introduce you to the basics of the control system. There is a plant. This plant is a system we want to control or to influence its behavior. The input for this plant is an actuating signal, and the output is a control variable. These inputs and outputs are referred to differently depending on the industry. However, we generally call them plant input and plant output. The goal of control system is to figure out how to generate the appropriate actuating signal to produce the desired plant output, which is control variable. Therefore, the control engineer must generate the correct input for the system to achieve the desired output. At this time, desired output means target value. For example, the target values could be 100 m, which is the distance to be reached, or 25 degrees, which is the setting temperature of an air conditioner. In feedback control, the system output, which is plant output, is fed back. Here, the system's output means the control variable. And the difference from the current system is confirmed by comparing this feedback with the target value. For example, when a person travels to the destination, which is 50 meters away, the person is a plant. The distance traveled by the person is the control variable, and 50 meters, which is the distance to the destination, is the target value. The difference between the target value and control variable is the error term. If the target value is the same as the system output, the error will be 0. The goal of the control system is to make this error 0. Then, how do we convert this error term into an appropriate actuating signal, which is the plant input, to make error term 0? The answer is the controller that makes this possible. A controller is composed of complex control algorithms and devices and has come to be called a control system. In this lecture, you will learn how to build a control system using CoLink. You will define RecurDyn's nonlinear dynamic system as a plant and create a controller that makes the error term 0 through co-simulation with RecurDyn and CoLink. Now, let me introduce RecurDyn and CoLink. RecurDyn is dynamics analysis software that provides a fast and efficient solver, an intuitive interface, and various libraries. It supports not only dynamic analysis of rigid bodies, but also nonlinear flexible body analysis considering large deformation or contact, control analysis, and optimal design, as well as co-simulation with fluid, MPS, and granule, DEM, using particle method. CoLink is a block diagram-based control analysis program built into RecurDyn. Complex control systems, or hydraulic/electrical systems, can be modeled using various blocks provided by CoLink. By simulating the existing control model with RecurDyn's dynamic model, it is possible to perform an integrated analysis of firmware design, electrical and electronic design, and mechanical design. A lot of control systems are designed based on the linear control theory. However, the actual mechanical system is mostly nonlinear. The example you see here is a stacker system for loading large packages. On the left is the rigid body model. It seems that there is no difficulty in controlling. However, in reality, the large structure as shown on the right shakes and vibrates. In addition to that, the contact of the rail moving up and down occur, which means such nonlinearity is included in real world. In order to simulate such a mechanical system, by including it in the control system, it should be expressed mathematically using a transfer function or a state space equation. However, it is difficult to build a mathematical model that takes into account nonlinearities, such as vibration and contact caused by deformation, as mentioned above. In this case, if you use co-simulation of RecurDyn and CoLink, It allows you to easily include the complex nonlinear mechanical system in the linear control model and perform a control simulation without mathematical modeling of the dynamic system. This is the end of the lecture. See you soon again in the next lecture. Thank you.